Welcome, beautiful peoples in Dark Core. The New Horizons mission has been a real space mission challenge, one of the toughest in human history. The probe reached Pluto and captured a view of the rock on the outskirts of our solar system that no one has ever seen before at such a close distance. Or maybe we're not the first to see it, because what New Horizons found has scientists questioning, is Pluto just a frigid, lifeless rock, or could there be more to this dwarf planet? 8 years later, the data collected during the flyby is still being studied by the mission team, providing new exciting discoveries and changing the way we look at the solar system. Is there really a hidden ocean of liquid water beneath Pluto's surface? What caused icy dunes across the planet's terrain? Learn about these fascinating things, about how the dwarf planet swaps material with its largest space neighbor, and more as we take you on a journey to Pluto, and see it like it's never been seen before. The New Horizons probe was launched on January 19, 2006. The primary goal of the mission was to study Pluto, once dubbed the most distant planet of the solar system. Back then, it wasn't possible to get a close-up look at Pluto, and scientists were really interested to see what the surface of the dwarf planet looked like. Because Pluto is so far away from Earth, the mission team had to come up with clever tricks to speed up the probe's journey, because otherwise it would take the probe a really long time to get there. After launch from Earth, in just under 9 hours, the New Horizons probe passed the Moon's orbit. While approaching the solar system's largest planet, Jupiter, the spacecraft took pictures of the gas giant and its moons. On Io, pronounced Io, the probe caught the Tvashtar volcano in action, capturing a volcanic eruption that reached 200 miles, 320 kilometers, into space. In 2007, the probe swung within 1.4 million miles of Jupiter, 2.3 million kilometers, and got a big gravity assist from the gas giant. This little maneuver massively reduced its time of arrival at Pluto from 14 to just 9 years, although an 8-year-long voyage was still ahead. To make sure the probe's electronics stayed in good shape, scientists put the spacecraft into hibernation mode. At one point, when New Horizons was at a distance of about 3 billion miles, 5 billion kilometers, away from Earth, the mission's team faced technical difficulties. Being that far away from the Sun, the 1,000-pound, 450 kilograms, probe didn't receive much sunlight to produce sufficient power, which led to problems with communication. The situation worsened the further the spacecraft traveled, and by the time New Horizons probe approached the dwarf planet, its signal would take about 4.5 hours to reach our planet. Approximately 4 months before approaching Pluto, the spacecraft cameras started revealing distinct features of the dwarf planet. From that moment on, the level of details in New Horizons images increased every week. Another challenge during the mission was the discovery of Kerberos and STYX, the 2 new moons orbiting the dwarf planet. This meant there could be a lot more space rocks and dust around Pluto than previously thought. Researchers had to figure out a way to avoid any potential problems if there was more debris near Pluto. The mission team had 2 backup options: to either use the antenna acting as a shield against the incoming particles, or to approach the dwarf planet closer than initially planned, where there might be less debris. Then, 10 days before the spacecraft's nearest approach, something unexpected happened. The New Horizons probe entered safe mode, and astronomers lost contact with the spacecraft. Luckily, it was just an overload on the computer, a problem with the spacecraft's command sequence. The team quickly regained control of the probe and decided to take a safety measure, retrieve a special set of data in case something goes wrong after the spacecraft turns away from Earth for its closest encounter with Pluto. The fail-safe batch of data contained images humanity would have missed forever were something terrible to happen, and the safety measure hadn't been taken. Nobody would ever see the stunning image of Pluto with its famous heart-shaped spot, this compilation of images showing the dwarf planet from different angles, or Pluto's moon Charon in vibrant colors. On July 15, 2015, the probe's messages reached the Mission Operations Base, notifying astronomers that 13 hours earlier New Horizons successfully passed above the surface of Pluto at an altitude of 4,800 miles, 7,800 kilometers, taking hundreds of images, and gathering scientific data about the dwarf planet's atmosphere and its satellites. But retrieving that data was no easy task. If you think the download speeds from your internet provider are slow, then check this out. The download of the estimated 6.25 gigabytes took a whopping 15 months to get. The probe could only send out 1 to 2 kilobits of data per second, all because of the vast distance separating New Horizons and Earth. But despite this, it was worth the wait. For the very first time, humanity got a detailed close-up view of Pluto's mountainous terrain, with some peaks reaching heights of 11,000 feet, 3,500 meters, and one that's made of ice instead of rock. Researchers believe the icy mountain range is no older than 100 million years, and is a potential sign of recent geological activity. And here's another close-up snapshot, but this one is of Charon's surface, showing evidence of landslides that happened sometime in the past. New Horizons has also captured multiple breathtaking haze layers around Pluto's atmosphere, extending up to 125 miles, 200 kilometers, above the celestial body surface. The hazes form when ultraviolet sunlight breaks down methane gas particles in Pluto's atmosphere. Then, methane forms more complicated gases like ethylene and acetylene, which the probe previously detected in the dwarf planet's air. These gases fall to the colder parts of the atmosphere and turn into ice particles that appear as haze layers. This alien atmosphere tells researchers a lot about what's happening down on Pluto's surface. There, the sunlight transforms a haze into tholins or dark hydrocarbons that make parts of Pluto's surface reddish. Close to the largest of them is a white heart-shaped region, where a 600-mile, 1,000 kilometers, nitrogen glacier named Sputnik Planitia is located. The glacier is so large, it has no equal in the entire solar system. Astronomers think it a relatively new feature on Pluto's surface, and a quite mysterious one as its origins are still unknown, although some researchers think it's an impact crater. And there's a lot of weird stuff going on there. One of those weird things is that on Pluto, ice turns into gas. Ice has one unique feature called sublimation. If you leave it in a freezer for an extended period of time, it would eventually disappear. This happens as ice slowly transitions from a solid to a gaseous state, skipping the liquid in-between stage because the right temperature doesn't allow it to melt. The surface region of Sputnik Planitia is covered with geometric shapes made of nitrogen ice, which long puzzled scientists. One possible explanation is that the icy surface of Pluto experiences the same effect, but the ice deposits that aren't consistent all across the surface. When ice on the dwarf planet shrinks, it creates bizarre polygon patterns scattered around Sputnik Planitia that look like icy dunes. Sublimation of ice also creates ridges or blades of ice on Pluto. We have something like that on our planet too. Scientists call them penitentes. But unlike several meter-high ice pillars that form on Earth, on Pluto, they can grow much bigger, to the size of skyscrapers, stretching for hundreds of feet high, where methane freezes and evaporates during warmer periods. As this freezing and evaporating continues for millions of years, ice deforms, taking on the shape of blades. Another puzzle behind Sputnik Planitia is its location. Scientists think the region could have moved vast distances across Pluto's surface in the past. They call the process behind this movement polar wonder, and if scientists are right, Sputnik Planitia might be responsible for the rotation of the entire dwarf planet. The famous heart-shaped region on Pluto experiences a positive gravitational anomaly. Gravity there is unlike anywhere else on its terrain, and because of this, it significantly affects the dwarf planet's rotation. You can achieve the same effect if you stick something heavy on one side of a spinning object, like a frisbee. According to scientific models, this is how the large glacier happened to be located directly opposite of Charon. One theory is that the hidden mass beneath Sputnik Planitia is an ocean, which isn't an absurd idea. Data from a New Horizons spacecraft demonstrated that both Pluto and Charon are complex celestial bodies with signs of recent geologic and tectonic activity, which indicates a past subsurface ocean on Charon, and a possibility of one existing on the dwarf planet even today. So is it theoretically possible life could evolve on such a distant cold rock? On Earth and the Moon, seismometers track waves generated by events like earthquakes. The speed at which these waves travel through different materials tells us about the composition and structure of the celestial object's interior or its inner layers. In a similar way, during an ultrasound medical examination, sound waves are used to create images of the inside of the human body. The waves bounce back differently depending on the density of the tissues they encounter, which lets medical professionals see internal organs. However, on distant worlds, where there are no seismometers, astronomers speculate on the layer composition based on the celestial object's density. They can then build models based on the most likely materials, like rock and ice. In one of such models, scientists suggested that there's a hot, gooey asphalt layer beneath Pluto's surface. Initially, it was organic matter, like carbon, which under extreme pressure and temperature can turn into a thick, tar-like substance. Kuiper Belt objects usually contain lots of organic matter, and if Pluto also had some of this material in its crust, with time, it could have evolved a 60-mile, 100-kilometer thickened organic layer. Depending on conditions inside Pluto and its chemistry, the layer might have a form of liquid asphalt or solid carbon, like graphite, and it might be mixed with a liquid subsurface ocean. But how could a world that's separated from the sun by billions of miles manage to keep that water from freezing for so long? Billions of years ago, chunks of rock, ice, and dust slowly clumped together to create Pluto and other solar system objects. When the dwarf planet grew big enough, the heat left from its formation could melt chunks of ice that make up a portion of Pluto. This theory works well if we assume a hot beginning. But how can we know for sure if Pluto started out hot or cold? When liquid water reaches a certain temperature, it turns solid, creating cracks along its surface. This happens because water expands when it freezes. You can test this by filling a glass full of water and freezing it overnight. In the morning, you will find that the glass is broken because of the pressure being released as the freezing water expands. Something similar happens on Pluto, just much slower. Frozen water is also less dense, which is why ice can float in liquid water. If Pluto had a hot formation, it should have clear signs of this. Its surface would have expanded and cracked as it slowly cooled. And if the dwarf planet started out cold, astronomers should be able to see signs of the opposite, compression in Pluto's past. The New Horizons has shown scientists craters on Pluto that are nearly as old as our solar system, none of which are compressed. In one study, where researchers theorized there's an ocean below Sputnik Planitia, they suggested it could be filled with large amounts of ammonia. If that was found to be true, the subsurface ocean wouldn't be like liquid water, but rather syrupy. Ammonia within it would be colorless and have an intense, suffocating odor. But what's fascinating is that this chemical compound of nitrogen and hydrogen is one of the ingredients for life. And not just that. When ammonia comes in contact with water, it causes a chemical reaction, and the molecule acts as antifreeze, keeping that water warmer than it would have been otherwise. If other dwarf planets and large icy moons in our solar system began their journey like Pluto, Earth might not be the sole celestial body harboring a liquid ocean and potential life within. Our solar system could be a vast reservoir of water, both its inner and outer parts, with a variety of aquatic environments. In the scientific community, there's an idea that the evolution of life might be more favorable in a subsurface ocean than on the surface of a celestial body. Even if separated by billions of miles from the sun, subsurface oceans could be warmed by geological processes, and life within them will be shielded from asteroid impacts and deadly radiation. Whether something like this is possible or not remains to be discovered in the future. During the probe retreat from the dwarf planet, it made its final, high-resolution images of Pluto and its mesmerizing haze. Overall, the spacecraft has made more than 200 scientific observations of the Pluto system, including its 5 moons. And right now, New Horizons is still wandering the Kuiper Belt after studying a binary trans-Neptunian object Arrokoth. For decades to come, no other probe will discover this realm of icy celestial bodies. And who knows, perhaps, it can surprise us with another mysterious finding in the near future. As technologies evolve, so does our understanding of the cosmic neighborhood. Do you believe we will find that the solar system is full of liquid water and potential for life? Let us know what you think in the comments below. We read them all. Stay tuned here for more thrilling space discoveries, and thanks for watching Dark Core.